Hello everyone. This session is recorded. If the people watching this are online when this is recording, just for the record, this is like 1 hour showcase of some stuff with tools for the public, so you guys in the call know who you are. But basically, adults who are not familiar with coding, that's the public. If you know very well Python and all of this, this is going to be redundant. But I'm going to assume that you're not familiar with coding. You want to use large language models in a more advanced ways or embeddings, and you can just basically use code just by copy pasting code and changing a few settings and not understanding the code. But I want to show you Colab, which is the Google online platform for doing Python, how it works, what it looks like, and how Gemini that is embedded in Colab can help you to find your way, even though you don't know how to code. So Collab is a Gemini is like an LLM that helps you coding that you can find in Google Colab. So basically what I want to cover today, I'm going to show you how to use Google Colab in copy paste mode. So, not understanding the code, but just changing it, how to use Gemini with it. Very, very basic knowledge about how to read Python. So what should you expect if you've never really looked into the code, like what is a comment and what is the function, what is a variable. How to use an LLM with an API, which is a demand I had from you. So from code, you can, remotely action a large language model. I'm going to show you what you need to do in the backend. I'm going to use ChatGPT here in this case. So what does the backend look like on OpenAI side? How to compute embedding, and if we have time, I will try to show you how to use data map plot, which is one library that you can use to make a semantic map of documents. And we're going to look a little bit into these documents. Let me share my screen. My screen, I want to share this window. You should see my screen right now, do you? Good. So this is the drive that I have shared with you. Let me paste that in the call itself. Where can I find the chat of the call? Here it is. Okay, so first, let's create a new collab. Just for me to show you what it looks like. Can I do that from here? I guess so. Google Collaboratory, that's how it's called. I'm going to create a test collab in this. Okay, maybe zoom in a little bit. So this is a collab, and it works with a number of cells. So for example, I could write some code, say x is equal 2 plus 2, and then print x. And then if I run this, sorry, I have some sessions running. Let me just forget about that. If you do it, it's going to work. It's just that Collab is for free, so you can't run as many collabs as you would like one at the same time, or like 2 or 3 is fine. Yeah, so this is going to print 4 because 4 is equal to 2 plus 2. So I am executing Python code here. Something you should know about Python code to talk about that is that you can write comments. So anything that starts with this sharp is a comment. So if I run this, the line "this is a comment" is not going to be code. It's just like for you to read what it does. If I remove the sharp, it's going to try to understand this as code, and then it's going to not work. Right? This is not a valid Python line, sure. So then you have an error, okay, and then it works. But so this is how you paste code into those cells and you run them, and you can create a new code, and you can say, okay, print x times 3, play this 12, because 12 is 4 times 3. Okay, so you can have your code can be separated into as many cells as you want, and you can basically move those cells around, and you could have some cells that could be text. This is text. So those, if you render them, they are just documenting this. So this is why we call them notebooks. The idea is that when I share that with you, you will have some cells that you need to run, and some cells that are just documentation, and that are just explaining what is going on. So you have a mix of this. Something else I need to show you is that the output of a cell could be some information. So for example, here I said print x, and it output 4. So I could say, for example, print blah blah blah, comma x. Oops. Right, but I could also just output x. It also works. I could also output any computation here. This is going to be relevant later on, because I could also output a table or some things like that. So basically you could use the notebook as an interface to do some data science by outputting charts and complex text and so on and so forth. You will see that later on. So just to mention this, the output of a cell is sometimes useful. That is why you would have your code separated into multiple cells, because they have outputs that are relevant to you. Also note that the order you run the cells matter. So for example, here x is equal to 4. Now, and then x times 3 is equal to 12. But now I could change x to giving it a different value. And then I could also change it after that to yet another value. And then if I run this cell it's not in order. That's what I want to precise. It really depends on which order you run the cells. Quick shortcut, you don't always see me pushing the little play button. I do Shift Enter, and this just runs the cell and goes to the next one. So you can go Shift Enter, Shift Enter, Shift Enter. It runs all of the cells, and you can also just do Run All. So if you do that, all the cells are going to be running. There is something else I need to show you with this. So basically, what is happening under the hood is that Google's infrastructure is spawning a virtual machine that is kind of given to you for a limited time for free. So it's like a virtual mini server with its own file system and Python running and so on. The first thing that is important is whatever you do here, once you leave, once the notebook is not used anymore, after, I don't know, 5 minutes or so, Google deletes the machine, the virtual machine, so that someone else can reuse the computing power. Everything you have saved disappears. So you have to download whatever outputs. If you create files, you have to download them before you leave, else they will be lost forever. Unless you have specific things that write directly on the remote file, whatever. You can do whatever you want with Python, so you could be more sophisticated. But just for you, if you use that in a simple way, remember to download your files. It also means that if you have to give a file, you have to upload it in the machine. How do you see the machine? You have a little sidebar here on the left. Most of the sidebar, it could be like the table of content or stuff like this, but the bottom icon here shows you the content of the virtual machine. And that is where you would upload some files. So for example, I could say, okay, I'm going to take this file, sustainability report, and I'm going to move it here. I get a warning and show that your files are saved elsewhere. This is the warning I have been, making to you just before. The runtime, it means this virtual machine. The runtime, the files in the runtime will be deleted when the runtime is terminated. Okay. And now I have uploaded a little file here. And then I could read it with the code. We will do that later. But understand that Google Colab is essentially a virtual machine you act on remotely through the notebook interface, and it is just temporary. Do you have any questions about that?
I have one question. So I haven't used Google Colab before, but are there any restrictions as to which modules I can use, or do you do the whole pip install and all that, or can you make a?
So first of all, excellent question. So because the machine is temporary, you can trash it. You can do whatever you want. Worst case scenario, you can even go runtime, restart the session. You could even go like disconnect and delete the runtime and respawn it again. So every time it will become fresh new. And you can install. So basically, if you need to install some dependencies, which we will do, normally you would go into the command line and go pip install. But here, this is not a command line. But you can do pip install. Basically, you need a bang first. You could say bang, so exclamation point, pip install ChromaDB, which is one of those. So for example, let me explain that for everyone. Let's say you want to import NumPy. This is a very well-known library. Let's try to run this. It works. Collab comes instantly loaded by default with NumPy. Okay, that's great. Does it come with ChromaDB? No, it doesn't know it. If I try to import it, it doesn't know it. So I need to install it before. So I can go bang, pip, install ChromaDB, run this. You're going to have a big series of lines. It's downloaded, whatever. You can ignore them, but it's just useful to show them, just to monitor that it is going well. It's going to take some time. And of course, this does not apply to all your notebooks, just this virtual machine this time. Next time you come back, you will respawn a brand new machine. You will have to reinstall, and this code will rerun. Now, I just have to say, if you rerun this right now, after it's finished, let me go on top. It's finished now. This is no longer running. If I run it again, it's going to say, okay, I have it. Requirement already satisfied, whatever. And now I can go import. Import ChromaDB. Now it's going to work. Of course, I should have that below. It should be better. First I install, then I import. So this is how you can do some command lines. Command lines are accessible with the bang command line, and this is gonna work most of the time. But that's how you would install additional libraries that else you would not have. I mean, that's one of the ways, at least. Any other questions? Good. So that's my demo. I think that you've seen enough of Python. The most important thing to understand is just that whatever starts with a hash is a comment, and then it's going to be displayed in green. This is going to help you parse the code I'm going to show you now. And then you will also see this pip install stuff, this import stuff. And then, so once you have ChromaDB, you can do some things with ChromaDB. Basically, it has methods embedded. That's why you would import it. It does some stuff for you. And most of what you would be doing with Python in this context is plumbing. You will use the methods you have imported to do things and then obtain variables that you pass on to other methods. So you will be plugging things together into a bigger machinery. And you don't have to really code an algorithm or whatever like this. You just use the stuff. Okay, let's close this demo. Okay, first, what should I do now? I should show you how to connect remotely with a large language model. And I'm going to be super basic. So I'm going to use this notebook, very basic OpenAI API connection. Okay. It has basically 2 cells. It's like dead simple. But we have other stuff to do somewhere else. So this is code you could reuse. And as always, here with the notebooks I show you, what you could try to do first is run all, and let's see if it works. So once you do this, some things are going to happen. Let's see if this works. It takes some time to spawn the machine at first. Okay, it doesn't work. We have an issue. This comes from the fact that you need an API key. You will not be able to use the large language model for free. Right? So this part of the code, let me just explain quickly what the code does. First, let's start here. We have a library that is OpenAI. OpenAI is by default in Collab. So Collab knows it. We don't have to import it. This is a comment. It explains basically what this cell does. It sets up the connection to the API. So we import the OpenAI stuff, and then we create a client that is using this API key. So just before that, we declare what the API key is. But you need one. I'm going to show you how to get one. And then this cell, it has like a little bit complicated code. You don't really have to understand the details of this, but essentially, this is a prompt. Write a limerick about a lemon pie. I'm going to come back to the prompt, but first, let's see how we get the API key. So essentially, if you go to OpenAI, you will need an account, and you will need to put some money in. And if you do not use OpenAI, you can also have stuff like Together AI, for example. This is another place where you could have access to an API endpoint that works like OpenAI, but you have access to other models and so on. So I'm showing you OpenAI, but you have other options. And I need to log in into the API platform. So I'm going to go, log in into the API platform. I am now logged in. If it's you, you have to create an account maybe, or if you have one, you have to, go through the login process. I was already logged in just before. And now so you have some help and whatever, but you need to create an API key. So where is that? Settings, API keys. Let me delete the one I had created just before. Okay, so you would have maybe no key like me, and I'm going to create a new secret key. Okay, my test key. Yes, it's good. This is going to go into the default project. Whatever this is, you can create keys for different projects and so on. Create a secret key. And now I have the key. So now anyone who has this key can essentially use ChatGPT with my money, which is why I will delete this key after this video. And now if I run my code, this is going to work. And it's going to take some time. I will come back to it. I'm going to let it run. Let me just show you. So this key is here. I could manage it. I could change the permissions. I could delete it. That's what I'm going to do after that. But it will work only if you have put money in your account. So if you go to the menu and you go to billing, you will see my credit balance. This morning I had put $10. And now I'm using it a little bit, and you see my money being used here. Okay. The code has completed, and GPT-5 has written for me the poem I had asked. So let me show you how it's done, because you have this. I'm not going to explain the library exactly. I'm going to show you maybe a little bit where the documentation is, where you could know what you could do. But essentially, forget about the syntax. You have to copy paste it. You don't have to understand it. The thing that is relevant here is you have a model. So GPT-5 is a model you can use, but you could choose another one, a cheaper one. And then those models, you write the prompt in two parts. You have the system prompt. So the role, system, and then this defines kind of the personality of the chat. So here I wrote, okay, you are a poetic literary assistant. Pretend you're sarcastic. Feel free to roast me and give me tough love advice. That's the personality I set for the bot. And then I have role user. This is more like the task, the kind of things you would actually type. So the personality is set once and for all, and then the little prompts you would have in the chat are the role user prompts. And then this is the task: write a limerick about a lemon pie. And then I run it through the thing, and then it gives me the answer. And this is the answer. So I remotely chatted with ChatGPT with GPT-5. Do you have any questions about this? So if you go into the documentation, you can see the many. You have an example here. Is this even Python? No, this is JavaScript. There is an API documentation. So for example, here it starts with browse models. You can see every models they have. GPT-5 is the most expensive. They have different price points. I don't know where we can see this. Where can I see the price? Yeah. The price is, I think it's like for 1 million tokens, 1,000 tokens. I don't know how many tokens this price is. I don't know the price structure very well. So you would have to, to read that a little bit in detail. Okay. Yeah. This is the per 1 million token. So you can see here 125. If I go for a cheaper model like Nano, 0.05, less quality, less big token windows, but cheaper. GPT 4.1 input $2. So they have, you would have to look at that. Pro $15. Okay, so the prices vary wildly. I would always go for a cheap one if I can. So how do you do that with a different model? In your code, you say, okay, GPT-5 Nano. I don't know exactly if is this a good model? No, the input is not good. Show me an example. Okay, this is how it's written. You could even say like this, I guess. Let me try this. Yeah, this works. And my query is going to be cheaper. I see.
Something?
Yes, go ahead.
Is there any way of knowing how many tokens you're going to use on something? I was trying to do a graph RAG thing, but I have no idea how many tokens that would, take.
Yeah. Okay. So how many tokens you have? You have to try. There are different ways you can see this. So first of all, I guess in your own. No, sorry. In your settings in the platform, in billings, usage. Okay, so you can see in usage how many queries you've made and blah blah blah. So maybe here you can see how many tokens you've consumed. Yeah, so you have like an overall idea. So this could allow you to monitor the number of tokens you use, I don't know, per day or per work session, or have an overview of this. What is your general consumption of tokens? And then I am assuming that the API documentation shows you how many tokens you generate. So then you will have to go into the documentation of the API. I don't know, you have to go through this. I am not going to do that now because it would eat a lot of time and it's not super useful, but I don't know, can I search for token count? Yeah, get input token counts. So that's something you could ask the API or compute in some way. You have some example code. Yeah, maybe it's in the response. Maybe can I actually see this? So what is in this? I have many things here. Yeah. you have some information, total tokens, prompt tokens, completion tokens. You have some counts as information in your query, right? I think this is a little bit too advanced for this this session, but basically, if you're comfortable with the code, the API gives you access to those management tools that allow you to control how much you're consuming, to prepare, to anticipate potential issues. The API can, for example, not crash, but send you an error if you send too many tokens for what the model can accept. It doesn't accept an infinity of token, only a certain number. Bigger models accept more tokens, smaller models less tokens. So,
but you don't need to spend too much time there. I was just wondering because I ran into it yesterday.
No, but that's a good question. I'm not going to show you, but I want to be clear about the fact that in a practical situation, you absolutely need to do that, and the API gives you the tools to do it. Right? I'm just showing the way, and you have to go through that door if you want, but everything is there. You just have to learn how to do it. Let me do something else, because now that we have a practical situation within Collab. You could, let me delete that cell. Let's say you have this question. You could ask Gemini. So let me do it. I could, in this cell, so this is like a Google Colab feature. I am in this cell here, and I'm going to click on generate, this little thing here. And this opens the prompt where I can talk to the embedded Gemini within Collab. I could also do this. Let me close it by clicking the blue button here. This interface changes a lot, so if you're online and you see this video 1 year ahead from here, probably it looks different now, but that's how it works. So basically what you do here, you could say, show me how many tokens I have consumed. And Gemini is trying to generate the code that does that, so let's see how it understands my query. But basically, it has access to the entirety of the notebook, and it's going to propose something. So it has deleted some rows in red, created some rows in green, and I can go here. So this is Gemini's answer, sure, blah, blah, blah. You can accept, cancel, so you can review what it proposes, and you can say, oh, no. But I think it's fine. I'm going to go accept and run. And then it's going to write the thing. And if it has an error, because Gemini made the mistake, it's going to retrigger, it's going to try to correct itself and propose a new thing. Now, if what you ask is too advanced, it's going to fail and fail and fail and fail and get lost. But if you ask for relatively simple things, so it's up to you to try to formulate what you need the best way possible and try to understand what's going on, you can do quite a lot without even knowing how to write Python. So you can explain what those three numbers are. Right, and maybe it's going to, I don't know if it can explain or not, and I don't know if I should trust it if it does, but you know the drill. So, yeah. Okay, it explains it right here. Okay. I thought maybe it could explain in the code, whatever. Add code comment for the record. Yeah. Okay. I see a question in the chat. Is it a question? In Google AI Studio, you have a free API key for Gemini. Okay, so if you have a Google account, apparently you can go with a free API key. Fantastic. Oh, it commented all my code. Great. So something you can do is you can also import some code that comes from somewhere and ask Gemini to comment what it's doing. No guarantees that it explains what it actually does, but potentially useful. Okay, so this was how to remotely use a large language model. I am now going to delete my API key so that people don't use my money. Also, just so that you know, I have a limit. I have put like $10, right? So you can see my balance. If it goes to zero, is not going to work. So your API will say, okay, you have no more credit. So I would not lose more than $10. So no big risks here. And you can also set in the API usage limits and so on. Even if you could allow the automatic renewal because you have one project that requires it, but some keys may be limited and others may be illimited or whatever. Yeah. Now I'm going to delete this. Revoke the key. This is going to stop working. And here I will revert the notebook in how it was before. Paste here your API key. And I am saving the notebook for you. Okay. Unless you have more questions, I will be moving on to another one. I will show you how to chunk a document, which is a step we need to do if we want to run embedding models or other kinds of text processing stuff. And I'm going to do it a very basic way, right? You have more advanced ways to do it, but here is very simple. And I'm going to show you what the code does. You don't have to understand the syntax, but it's just so that you have a general idea of what's going on. I could just go run all, and it's not going to work. Yes, I have too many sessions, killing the sessions that are not needed. Run all. And that's because the source document, which is here by default, this little document here, has not been uploaded. So I will need to do that here on the left. And if you want to do it, the PDF in question is here. I just use that as an example, but you can use the idea that you use your own PDF. But basically, I use something that is relatively short. So this is the 2023 sustainability report by Wonderful Copenhagen that is freely accessible online. Not too much text in this PDF. That's why I took it, because we don't have a lot of time, in the sense that some of the stuff I would like to show you takes time to compute. But if it's you don't care, because you can let the Collab do its thing during the night or whatever. Okay, so I'm going to upload this file here in the virtual machine. And then I'm going to run all again. So first, I am declaring what is the name of the source document. This is what this does. Then I have this pip install line. I needed to install a library that is not by default in Collab. It's called PyPDF2. Basically, it extracts text from PDF, which is what we want here. Then I have a cell where I import libraries. So they do various things. You don't really have to understand it, but just for your culture. So Pandas is a data management system, if you want. You can load tables and they're going to be displayed as tables and so on. So it's convenient. And NLTK is the Natural Language Processing Toolkit. It's a generic, well-known classic library for working with text in Python. And essentially what I want here is this little bit, sent tokenize, which is a sentence tokenizer. So what it means is that it extracts the sentences from the text. That it's as simple as that. So the chunking, I want to separate my big document into smaller pieces that we're going to call chunks. They will be my sentences. You could do it different way, but I will just keep it super simple for now. So this is just preparation stuff. And then, as you can see from the top comment, this cell extracts the sentences from the document. I'm not going to go into the details, but essentially I have a PDF reader machine that is going to look at the document I have specified on top, is going to extract the text, and then the sentence tokenizer is going to extract the sentences, and then I will just save them as chunks into a data frame, which is the table in the language of pandas, whatever that is, but basically you get this table where you have the chunks, so the column chunk contains the text, and I just added something else, which is the chunk position. If I wanted to reconstruct the text, I would like to know which sentence comes after which one, and this encodes the position of the chunks. You could go much more sophisticated, you could load many documents and so on. But basically that's all it does, and it saves the document as a CSV that is called chunks.csv, and that you would need to download. So how to download from here? You go into the 3 little dots, download, and it's going to come in your actual hard drive. And let me open that in a oh, come on, sorry. Yes. So here you have the little sentences as extracted by the tokenizer from the PDF. And you can do whatever you want with this, which also means you may have another pipeline with your own data to obtain a CSV, but if this is a good way, you could repurpose that code here, copy paste and ask Gemini to adapt it so that you obtain exactly the kind of document you would like to have. So, yeah. Now I want to visualize the chunks, essentially. And here I have like 155, so not too many. The map I'm going to obtain then is not going to be super interesting, but at least it's short. Any questions about this? You seem good with that? Good. So this was chunking, and then we go into the more advanced kind of collabs I wanted. So I wanted to show you that data map plot, but I lacked the time. In the time I had, I did not succeed in having something that was very readable, because their example, they are very big and a little bit complex, and the code would not run on time. So I will be trying to show you this other piece of code that does not use data map plot, but it shows something you can reuse. Fantastic. Okay. So this machine was already running. Let me just restart. I'm going to restart this. And let me just... Okay. So the idea here would be to visualize a set of documents, and it uses the kind of chunking we've done. But the idea would be that you can upload as many PDFs as you want. I will just upload one, because we don't have the time, because it may take like 15 minutes to run, which is not that much for you, but for us right now it is. So I will just have one document, and I'm going to use the same small PDF. But the typical use case I wanted here would be, but it takes too long, I would upload I have like 6 years of Ørsted reports, and I could compare them. or whatever. But this is a good case. It's a real world case, and we could see how the language, the arguments of Ørsted in their own reports changed over those years that go over the COVID period. So this would work for you with really real world data. Here I will just stay super simple. So the way this works is you need to add a folder named documents, and you need some PDFs in that. So you would do that on the left. So I created this. So how do you create a folder? You right click new folder, and then you go into your folder and you right click upload, menu upload, and then you upload in your folder whatever PDFs you want. So here I just have one. And then you run all the cells, and maybe I can just run them all in a row. We have, once again, this kind of install line. This is going to take some time. It outputs a lot of stuff, but you can ignore it, basically. So now we have like a real notebook that takes time. So I can show you this. When some cells are waiting for the cells above to run, they have this little turning wheel. It means, okay, those are waiting. Of course, the notebook does not run all the cells in parallel. It waits. Okay, so now the time for this one. This is the importing stuff. Once again, it does nothing. It just loads. Now, sometimes what you load takes a little bit of time to load. Then we would have exactly, it's just a variation, but it does the same as the chunking. So it's chunking my PDF exactly like we did before, which means that you could chunk it once and for all and then load it at this point instead. Then I shuffle, I have some randomization here. I'm not going to explain why, but it is useful to the results. Then I need to import something that is called ChromaDB, which is the thing I used with you guys when we did this exercise with your sentences. So ChromaDB is a vector store. What it does is you give it your pieces of text, your chunks, or your documents, and it's going to embed it. Do I specify here which model I use? No, I don't. So I just use the default model, but you could specify what model ChromaDB is supposed to use. I've covered that with you in another place, but basically, if you go on Hugging Face, you have a lot of models here, and basically the one we use here are sentence transformers, and you have many different ones. This one, All Mini LM L6v2, is, I believe, the default one for ChromaDB, but you have others. So you could go shop for the model that works best for you. I'm going to leave that aside. So what this does is it's loading my chunks. It's transforming them through the embedding into vectors, and ChromaDB is going to store those vectors. And I could do many things here. I could search for them, and we will see that a little bit. Now, so I obtain my embeddings. Now I'm going to use UMAP, which is dimensionality reductions. Essentially, it makes a map with your vectors so that you can see them. And data-mapplot would do the same, but here I'm going to use something else, which is bokeh. And I'm still going to show you. Well, let's see if we have time. Else, I will share another notebook that you can reuse for data-mapplot. I need just a little bit more time. So here we have all the sentences from the PDF, and you can see that they draw a map. So we could try to understand what that is. So what is this cluster? It looks like it's the sentences in Danish, while many of the sentences are not in Danish. I'm not going to explore that here, but just to mention, so this plot that is rendered with bokeh, that's what this code here does, shows you the different documents you have. Here I have only one, and you can use it to explore and try to understand the geography of this. What data-mapplot does is that it produces an image that is static and maybe some more useful in some circumstances. And it also comes with another library called toponymy that basically does the UMAP for you, but you still have to compute the embedding. This is on you. But the good thing here is I can, okay. Let me take a sentence right here from this. So here I have a sentence about energy usage. I will ask a question, which will be like, how much, is it bad? How is energy relevant to sustainability goals? So I have written a question that is loosely relevant to the kind of document I have, to the kind of chunks I have. It's a sustainability report. Okay. And I wanted to show you what RAG does, which is something you can use with this notebook. So these are all our chunks. It's a map that we could explore visually to understand the structure, what the components are, what is this big part, what is this small part, and so on. But retrieval augmented generation, which is what RAG does, allows you to actually search in this. So the way it works is my query is embedded in this, and I can find, I've shown you this, but the red dots are the 1, 2, 3, 4, 5, 6. Why do I have 6? Did I ask for 6 documents? Yes. I asked for the 6 chunks that are the closest to my query. And I got them, and I can just display them. Wait a minute. Here they are. So I have found the 6 sentences that are the closest to my questions, to my question here. You can see, so we can discuss whether those are actually good sentences or not. Maybe the tokenization is not that great. Some problems may arise. That's why you can see this. You can also challenge if the model is good enough to associate those sentences with your query. Different models have different properties. So we got those 6 sentences, and basically what you would do if you wanted. So this is kind of RAG in Kit, is you could run this little code here, which takes my sentences and it assembles them into something that you could paste into a large language model. So let me do this. I would go on ChatGPT and then I would paste this. Oh, yes. What happened? Let me unpack this. So what you see here in my query is what I am asking to ChatGPT is look at this JSON. So it's like a datafied version of my sentences. So this is just the code version of my sentences given as a list. And then I say, given the context information above and not prior knowledge, which is, I expect it to ignore its prior knowledge. It's not going to do it, but it's better than nothing. Answer the query below. How is energy relevant to sustainability goals? And then hopefully it would try to give me an answer that comes from my documents. So this is a little bit of a dumb example, but you have kind of a pipeline that you could use to build a small agent. Right, so basically here I have just generated this query and I have copy pasted it in there, but you could replace this with a remote prompt to an API and get your answer. So this is like a very basic plumbing, but it's one of the ways you could use documents or chunks of documents that are relevant to you in the way you want, and use a kind of a query system to draw on your documents using an embedding model to control the knowledge that you would pass on to a large language model to give you some answers. To put it just another way, you could just speak to any large language model. So you speak to the way it was trained, and this is going to ignore the data from your organization or from your case. But if you want to involve knowledge from your organization or your case or your examples or your project, you basically have to do that kind of thing. You have to have this information in a vector space, for example, in a vector database or another database of some sort. Could just be a traditional database if you want. And then you have to find a way to articulate it into something that you would pass on to a large language model for some tasks. That would be whatever you want. So that's the basic architecture. A retrieval part that I'm using with ChromaDB here, and a prompt part that is ending the chain so that a large language model gives you an answer that is easy to read. This notebook here is this one in the drive. So that's the point where the semantic maps as exploration interfaces also articulate with expert system you may design to obtain specific effects with your data. The code is a little bit advanced here, but you can maybe just by copy pasting it and changing a few things, it works enough for you. Any questions about this?
If no one else has questions, I just quickly wanted to ask you about, you talked about something called Misty as well, but I couldn't really find it when I just tried to Google it. You talked about it when we had our meeting. Yeah.
So I've not covered that today, and I didn't have the time to look in depth about it, but Misty is an alternative to Notebook LM. Right, so it's kind of a little bit different question. Maybe we'll see that next time. But so it does RAG, but in a way that is more integrated. Something that is worth saying at this point is that more integrated is not necessarily what you want. But Misty solves another issue, which is it can run on your machine. So what you've seen today, the code runs on Google Colab. So it goes to a third party, which is Google in this case. Now, how bad is it? I think that in practical terms, basically no one else would really have access to that virtual machine. It doesn't really go into the cloud like a centralized disk space and so on. So the fact that those virtual machines are hosted at Google rather than here, it doesn't make that much of a difference to me. In very, it comes with legal issues. But we also know that contrary to what Microsoft had said, but they have now admitted it, that when you have servers in Europe administered by Microsoft and they promise that it's GDPR compliant and so on, NSA and so on still have complete access to it and can steal your data. Right, so this is one of the reasons why we have this entire discussion about data sovereignty and computational sovereignty in Europe right now. So the fact, it would be very bad if it goes into your Google Drive, but that's not what happens with Google Colab. The Colab itself, the code is in your drive, but the data is not. It's in this virtual machine that disappears. Now, the part where you send the data to OpenAI, this is really bad. OpenAI is going to absolutely read what you sent and maybe train. And then someone, this is a complete leak. Someone could absolutely get that data and I don't know. This is super unsafe. And it's not just OpenAI. If you use Together AI or another system, presumably it's the same. So, but Python is a platform. So what you could do is you could use, but it's much more complicated. So I'm not showing that to you because you're not comfortable with the code. But you could prototype something on Collab and then not lose everything. You could then run that locally. The logic here would be you use those notebooks on a local infrastructure. That could be Anaconda, for example. Basically, Anaconda is like a framework where you have Jupyter notebooks in them. So you install that, you run that on your own computer, or VS Code does it as well. You have options. And then you would also replace the part where you speak to OpenAI with something that is computed locally, which means, of course, you would need a good machine. But for your organization, the structure of your code can be repurposed for a local thing. Now, local models are not going to be as good as GPT-5, but maybe you don't need GPT-5. So there's this entire discussion about what you have to do to run things locally. Misty is kind of the same kind of thing. If you can't use Notebook LM because it goes to Google, same issue as OpenAI, you can use Misty to have your RAG infrastructure run locally. I need time to get to know Misty, so maybe we'll see that next time. Feel free, so the session for today is basically done. Feel free to let me know if you want to know more tools, other kinds of tools. We kind of have some things that are already in the pipeline for next time, but we could have others and we could have another session. Let me know. Yeah, and I will leave this video in case you need to come back to it.